So, now say electric potential at a point due to an electric dipole. So, we have calculated electric potential due to a point charge. So, now let us calculate potential due to an electric dipole. Suppose there is a dipole, this is minus q charge and this is plus q charge. Dipole moment is to this side and distance between these two charges is 2a. Now, we have to calculate the potential at point P. So, this is the center of the dipole we take and position vector from this point is r, and position vector of point P from plus q is r1 and from here it is, that is r2, and this angle is suppose theta. So, now the total potential at point P can be written V is equal to V plus Q plus V minus Q. This is a scalar quantity, so it can be added algebraically. So, now V plus Q can be written here Q upon 4 pi epsilon naught R2 R1 and here plus minus Q upon 4 pi epsilon naught R2. So, we can write V is equal to Q upon 4 pi epsilon naught 1 upon R1 minus 1 upon R2. This is the total potential at point P, 1 upon Q upon 4 pi epsilon naught into 1 upon R1 minus 1 upon R2. So, now we have to calculate the value of 1 upon R1 and 1 upon R2 by using geometry. So, the total distance between minus q and plus q is 2a. So, we can take this is a vector and this is a vector. So, using the triangle of vector addition, we can write vector a plus vector r is equal to r2 and we can write a square plus r square plus 2ar cos theta is equal to r2 square. Now, we can write here r2 is equal to r2 square is equal to, we can take common r square, a square upon r square plus 1 2a upon r cos theta. See here a is much more less than r. So, this can be ignored and we will be getting r2 square is equal to r square into 1 plus 2a upon r cos theta. So, now here we can calculate the value of 1 upon r2, that is 1 upon r2 is equal to r 1 plus 2a upon r cos theta raised to power minus 1 by 2. I have taken square to this side and taken here the reciprocal, that is 1 upon r2. So, we can also write 1 upon r2 is equal to r into, that is 1 upon r, not r. So, here we can write 1 upon r and using binomial theorem we can write 1 minus a upon r cos theta. By the same method, using the triangle drawn, we can also calculate 1 upon r1 is equal to 1 upon r into 1 plus a upon r cos theta. Now, these two values we have to put in the equation. V is equal to q upon 4 pi epsilon naught 1 upon r1 minus 1 upon r2. So, now we have to put all these two values in this equation. So, now see by putting the value of 1 upon r1 and 1 upon r2, we get this relation here. We solve it. When we solve it, we can get q upon 4 pi epsilon naught r square and 2a cos theta, where q into 2a is the dipole moment. So, we can write p cos theta upon 4 pi epsilon naught r square. This can be also written V is equal to vector p dot r unit vector divided by 4 pi epsilon naught r square. So, basically potential at any point is the dot product of these two vectors. So, this is also a scalar quantity. So, this is here the potential at any point due to electric dipole, which is here inversely proportional to here we can write r square here. So, we can also calculate the potential at a point on the axis of the dipole and potential also at a point on the equatorial line of the dipole.